episode is brought to you by our members on YouTube and our private community. If you like the show and want to support us to keep the show running, please consider becoming a member or making a small donation using the links in the description of this episode. Hi everyone, in this episode I have the pleasure to speak with Dr. Zac Lamas, a postdoctoral honeybee researcher working at the USDA Honeybee Research Laboratory in Beltsville, Maryland. Dr. Lammas has been studying Varroa mites for several years now and is bringing new information about how this terrible mite transmits dangerous viruses to honeybees. In this conversation, we addressed one of his articles that shows that Varroa amplifies the distribution of Deformed Wing Virus and the techniques he used in his research. And now, I introduce to you Dr. Zac Lamas. I have the pleasure today, my friends, to have Zac Lamas with me today. Dr. Lamas is doing a fantastic job at the USDA right now, researching Varroa mites and its interactions in spreading viruses, and is adding new chapters in this whole story about how viruses and Varroa mite interact with each other. And today I have the pleasure to have him on. Hey, Zac, how are you? Welcome to the show.
Thanks, Umberto. I'm good. How are you today?
I'm great, and I'm much better now that you are here, and I'm looking for this conversation for a long time. We have had previous conversations in the past. I know you from your career a little bit, but I don't think people at home know your career the same way I do. So, and I think it's a great story, it's a great background. I'd like to start with that before we jump into the research that you were doing and the results, the interesting results that you got. So could you tell us a little bit about your background, how you get into bees? I know you're a beekeeper. Can you give us a little overview about your career?
Yeah, I mean, in brief, the beekeeping was an accident. At the time that I got into bees, my partner and I at the time had just bought this 23-acre parcel in New Hampshire, and we had been farming for years, but not on our own property. And we were doing pasture-raised poultry and selling raw milk. We just milked a handful of cows. And in New Hampshire, they have some really great lax homesteading laws, which allows you to sell to a local market. But we wanted to expand the business, and we thought doing a fall pumpkin patch would be an awesome way to get a lot of new customers from our area that didn't know about us. Because who doesn't like a pumpkin patch in the fall, especially up in, northern New England, where, winter's just going to crush you for the next few months. So I plowed up an acre and planted, harrowed it and plowed up and planted some pumpkins. And when I finished, I was like, man, that's going to be a lot of flowers. I should probably buy a beehive. And that was actually the start of my beekeeping. Long story short, it rained all summer. So the pumpkin patch went to hell, but the bees lived. And one of my raw milk customers, this lady named Ellen, she was a beekeeper, and I asked her next spring, what do I do with this colony? And she came over and helped me split it. Well, long story short, my partner at the time eventually went back to California. And, when you build such a thing together as a farm, it's emotionally impossible to continue it after your partner leaves. And she was gone, and I'm like, I can't milk these cows anymore. Not because you can't do it, it's just you used to do it always together. So I sold off everything in the farm, but we never did anything with the bees together, and neither did I. And I took a different full-time job to keep paying for the property, and I said, well, I want to still be outside. It's like an inherent part of me. I just need to be physical and outside, and especially that seasonality in New England that you can feel, just because we have such these different seasonal extremes. If I miss it, I can feel it, kind of take away from my soul. So I just did a couple hives, and someone handed me Mike Palmer's DVDs. If you can imagine at the time that you're getting all your information from handing you DVDs. And I saw this guy up in northern Vermont who was kind of seemingly skirting the CCD crisis by making his own queens and expanding his apiaries, this nucleus colony production. And I'm an inherently competitive person. I'm like, I could do that. And it was just arrogance, right? So I split out my colonies and persuaded my brother to load them in the back of his Mazda hatchback. And we drove down to North Carolina, where I had a friend who was a carpenter in New Hampshire, moved down there, and he hooked me up with this community garden. And long story short, I wanted to learn a lot about bees. So what I ended up doing was getting 2 springs a year. The season up in New Hampshire is so short. And as a new beekeeper, I realized very quickly that if I'd made mistakes, which you're going to do as a new beekeeper, the next thing I know, winter's around the corner. So then you got to restart everything the next spring. And I'm like, this is a horrible system to try to learn a new craft that's extremely dynamic and complex, and the conditions always change. So I gave myself 2 springs a year, because I'd go down to North Carolina and I'd get March, April, and early May down there. Then I'd take my hives back up to New Hampshire and I'd get May through late August. Now I have a huge continuous learning experience every year. Everyone thought I was doing it because my bees needed to go south to live. And I was like, no, this is for me. And in fact, I was waiting tables at this point and either driving or flying back and forth, like once a month in the winter just to check them. And I got a couple months off one spring, and I lived out of a tent on a friend's property down there. And I taught myself how to make cell builders, graft, and produce queens. And it was so inefficient, right? Like, you're just making tons of mistakes. But that was the purpose of this personal experience, right? Can I do it? Can I actually grow out my apiaries? And long story short, I ended up getting up to about 400 colonies and simultaneously working for Mike Palmer for a while, for a few years. And that was the amazing experience. I really needed to work with Mike to become a good beekeeper, that can work a large number of colonies systematically, because that was an unfamiliar concept to me, right? I just have a lot of colonies, but there's no systems in place. There's no standard operating procedures. And I, realized that this really needs to be more like a structured farming endeavor than what I was doing. And Mike taught me that just by working alongside him. So I managed his honey and new production for years. And, at one point, it was really bugging me in some ways how researchers talk to beekeepers. And, that bugged me a little, but it was also that just in the literature, and that comment that I just made right there is also coupled with, I always wanted to go back to grad school. I just didn't know how. Like, at the time, when my brother and I went off to college, my parents hadn't gone to college. They actually did this really cool thing that while we were in college, they wanted to go to college themselves. But there was no pathway or understanding of what it meant to go to college and how do you make a career in STEM. So that was all foreign to me. The real inspiration for that was this kind of these 2 introspective points. One was, I want to go back to grad school. I don't know what it means. Second, what researchers were publishing about mites killing colonies wasn't lining up with what I was observing in my own colonies. And at this point, I have hundreds of my own, plus all of Mike's that I'm taking care of. And it was this real simple question, which is, how can relatively few mites kill such a populous colony? I mean, there's tens of thousands of bees. We seemingly get a few hundred mites. How is it possible that they can kill these bees? And people will sometimes say, oh, you're really smart or something like that. I put my hands up. I'm like, no. Any of my collaborators that work with me long enough realize pretty quickly, I'm not that smart. I'm extremely creative and extremely stubborn. And I feel like that stubbornness, if you use it as a tool, can be a real asset. And once I asked that question, I was not going to let it go. And that actually became about a year and a half to find a program and get into one. But once I asked that question, I just wanted to pursue it. And it became the basis for my PhD thesis. And then the work that we're doing now is actually building off of essentially that one simple question that was asked years ago.
No, that's fantastic. So you are a true beekeeper, and that did your not transition, but you're doing both now, right? You're pursuing your career as a honeybee researcher, and also you still have your colonies, right?
I still have my colonies, but it's not so. Yeah, I pretty much stopped selling bees and rearing up my colonies during the year of my thesis. A lot of students will take a gap year.
Yep.
I took a gap decade between when I finished my undergrad and actually going to grad school. And I didn't want to go back I had been broke for years running my beekeeping business and building it up. I didn't want to, I finally got to a good point where I'm making some pretty decent cash, right? Now I'm going to give that up to go live off a graduate student stipend. I was like, hell no. I had been hungry before, and I'm adamant, I go into a grocery store, I don't look at the prices. If I want an avocado, I buy an avocado. And that was actually a value I had for going back into grad school. So I kept about 100 colonies, and I would produce nukes and queens and sell them while I was doing my PhD. And, but I got into my thesis year, and I was like, I cannot run this and focus intently on a thesis as I'm supposed to. So I just toned it right down from that year, sold tons of stuff off. And then for the first year and a half of my first into my second postdoc, I wanted to continue that. I really enjoyed not being split. And what I mean is you feel like you're juggling a couple different things. And then if you do that, you're not doing everything well. And so I was like, I don't want to get back into that. But now I've had a couple years since I've really run bees. And I feel like I'm looking at everything in a rear view mirror. and I could see some of the poor practices I had in terms of running a business where they could be improvements, some of the inefficiencies I've had. And then it's also given me this really great perspective where I'm like, I'm giving up something that I have domain expertise on that other researchers don't. And how can I actually run my own bees and then present that operation, to the beekeeping community, and everyone can get some value out of that. And it's actually something I'm in the process of now. So I actually plan on running probably a couple hundred colonies here in Maryland while I do this postdoc over a couple of years. And what I did was I built a standard operating procedure into that running those colonies based off of the findings the disease, the findings in terms of viral transmission and mite behavior. And so it's a really applied way to say, we want to run these bees with management thinking of disease ecology first. How can we document it and then present it in a way that it might be really useful to the beekeeping community and or, colleagues, that it's really difficult for us to find, a large number of colonies to work with at the same time. And the fact is, a couple hundred colonies of a forklift, it's really easy to run that on a, day and a half, a week or so. It's not like that much work.
That's why I like your story very much. Remember a little bit of my own path. And I think you're in a position that you're going to need to do some very interesting decisions right now. You have a good background from both worlds. The farming world, hands-on beekeeping, how to survive from the craft. Mm-hmm. And now you spend a good amount of your time in the academia world, in the research world, and they said sometimes they have some conflicts. I feel that sometimes in my story end up that I need to give up one. I couldn't stay in academia for too long. It was clear to me that for my skills, the thing that I can do to help the beekeepers would be better to stay out of academia and become completely independent. And I'm curious to see where you're gonna end up. Now you've been very successful. You have some very interesting papers. So you have the skills as a researcher now. You have the skills as a beekeeper. So I'm very curious about how the story is gonna end. So what are you gonna do next? Can you tell us a little bit about?
I can. Yeah. I mean, it's a real fun question, because I've had conversations with both, really close beekeeping colleagues and also close colleagues in research and academia. And I'm at a nice crossroads right now in terms of what do I want my career to look like. And if I had a crystal ball, of course, that'd make this all easier. Part of the things that I want that crystal ball to tell me are some things that have nothing to do with work, right? For example, my parents are, within a few years of retiring. Knowing how long they'll live would dramatically change my decision for my own career, right? Like, if they're going to live for 30 years, taking a research position far away isn't as scary as it would be as if they're going to pass away in 5 years, right? I wouldn't give up 5 years and a lot of contact with my family. That might affect some people hearing it if you have recent loss, but I always think about, in terms of what are my really core values and what are the things that get me up and drive me day to day. And if you're a close colleague of mine, I call you regularly, right? We do these long drives, both for research and to see my family. And I have friends that, they don't live near me, and I call you every week or every 2 weeks. I want to catch up with you. I want to know what's going on with your friends, with your kids, et cetera, right? And so that's core value I have. And, the other is I want to be able to retire well. I love the idea of working, but I've seen some people work their whole careers and not be able to save. And then they enter retirement and, they're still scrapping. And I'm like, well, I don't want that future for myself. And the nice thing is academic. So what I'm trying to say is there's multiple things that are going into calculation like everyone does. And I'm at a crossroads where I'm thinking of that. I think I got off a little bit too much of a tangent. So let me pause for a second. And then just to answer it clearly, I think there's no wrong decision in terms of where the career will go, as long as you feel like you're taking agency in that direction that you want to go into. And very often in our day-to-day lives, we'll give up that agency, right? We're hoping someone recognizes us. In academia, we say you need so many, you need a Nature publication so that universities will be interested in you. When you follow that model, you're giving up your own agency. You're taking the hands off of your own steering wheel and hoping someone else is going to be involved in the direction your career is going to go. I do not feel comfortable with that model. And instead of, worked with my mentees, and Jay is one of them, and our purpose when we show up to the lab and when we interact with beekeepers is to do really good work. That's it. It's not for a high impact journal. We do want it. It's a fun goal, right? But that's not the purpose. The purpose is to do really good work. So that's the first and foremost thing. And then if I'm doing really good work, those other little values I have, how do they fit into what I'm doing on a day-to-day basis? So for me, as an ideal job is one, I also get access to my family, right?
Yep.
So as long as I get that fulfillment, I'm happy. But in terms of, I want to stay in academia. I love doing research. So I really don't know. I kind of stammered a lot, but I think it might be a slight hybrid model, and I'm super comfortable with that. Some researchers I've shared it with really weren't, but I'll kind of pose it this way. I talk about running my own bees. Some people thought it meant like you're not taking your postdoc seriously, or it's going to be a distraction and you can't focus on research. And I really kind of turn it back, and I'm like, well, during my PhD, I used to keep colonies in North Carolina. And I would drive down there on spring break to make new colonies, but I would identify colonies that had high mites because they're, several months ahead of us on the coast there than in Maryland.
Yep.
And then in April, I would go down there, strap up the infested colonies with mites, drive them up to Maryland to my research yards. And then in early April, I had more Varroa than I ever needed to start doing research. Whereas a lot of researchers I were working with were saying you can't do mite research in Maryland until July. Right? Because you have to wait until they build up enough and we can collect enough mites to do the work. And I kept my own colonies partly because it was like, wait, that's a horrible model. I can beat that by simply doing this, right? And what it ended up allowing me to do is actually doing more research. And I had so many resources, I had to be creative to keep them alive, that it actually opened up more pathways for research. So when I've been thinking about terms of, how can we do public speaking and extension simultaneously with doing research? Well, if you approach something and you give something all the time in the world, then every single possibility of the work you could do enters your brain. It could be overwhelming. And people will sometimes have stasis paralysis by analysis. You have too many options. You don't know which one to take. Well, the moment I say, I'm going to work with this collaborator, I'm going to do this much work with them, or if I'm going to do this much work with Jay, it limits the time I could do on my own work. And if you pose that with this scarcity mentality, oh shit, I gave up my time for other people, I can't get my own stuff done. Okay, that's a scarcity mentality. That's a whiner's mentality. You have this abundance mentality. It's like, okay, I want to work with Jay because he's an amazing person. He's a great person, and I'll learn so much from him. I want to work with this collaborator because I really like to work with them. But now that I gave up 25% of my time, what do I do with the 75%? Well, by eliminating all of the options, the most important things to you are the only ones you can actually work with. So if you look at my research plan over the next 2 years, and I have this great NIFA funding, we actually just blocked out the absolute most important thing and the most impactful things that we want to do. And some of the things that we are interested in just have to disappear as a result. And so I really like working this way, and I'll go on these long walks and try to catch myself, right? Umberto, I don't know what your process is for having to reconnect.
Long walks, exactly.
So they work, and I'm the scary guy in my neighborhood where I'm talking to myself, right? Like I'm going on a long walk and I'll talk over a problem, but then I'll catch myself. The only reason I'm doing this project is I'm afraid of not having this finding. You thought about something you could have done, right? This happens with us researchers. We want our name behind it. And I'll catch myself and I'll be like, wait a minute, if that's the only reason I want to do this 2-month project, why am I doing it? Is it important for beekeepers?
Yeah.
Is it impactful for research? And long story short, we've had far simpler projects that aren't super sexy. They're not going to end up in a high impact journal, but we pursued them because, hey, we were aware of what we wanted to kind of pursue in this aspect. Well, you don't want to go there. Let's do this really high impact thing, even though it's not sexy. And that's in, I'll stop talking because I can see you want to move on. But
I'm laughing because it's part of the struggles I have in the past, and I'm kind of rewinding in my mind everything I was thinking of. And so the only thing I can tell you, just consider what is real value, what you bring to the table, calculate what that value is, and sell it accordingly, because you're a very unique position. And there are lots of opportunities out there, and academia is not the only one. So, but we can talk more about that offline on one of these days for this. But I just want to move forward because I am very curious about 2 of your publications. Let me put one on the screen right now so we can start this discussion, because you published these articles. Actually,
it's a mouthful, yeah.
I want to start with this one. I don't know if everybody can talk, because I can jump from this to the other one. I think is easier for the story. But you correct me if I'm wrong. So promiscuous feeding on multiple adult honeybee hosts amplifies the vectorial capacity of Varroa destructor. So you published this in January of 2023. There is it's a year and a couple months now old. Yep. What's the main message? What are your main findings here? And what did you add to the table regarding our understanding about Varroa virus interactions?
Yeah, if we were to do just one main finding.
Yeah, give me your overview, like your 5 minutes overview. What you got it, how it was done, and what were you impressed with this? Where you got and why?
Yeah, no. If we were to do one main finding, I can only say one thing about it. It's look at the mites inside of your colony, Varroa. They actually are more representative of a mosquito model than they are the model that we've been studying. And what I mean by that is mosquitoes, they are mobile across hosts. So they don't just feed on one host in a night or in an early morning. They move from one host to another in order to feed. And decades ago, we came up with this equation, vectorial capacity. And in that equation, the biting rate is one of the parameters, so one of the components that overwhelmingly drives disease transmission in the malaria models. And at the USDA, Matt Heerman and I were chatting. Matt, unfortunately, has passed away since 2020. But he was this postdoc, and he understood I was talking about something, but didn't know that there was already a lot of work done in mosquito biology. So he just kind of gave me a little nudge. Go check that out. Man, I did like a Google binge search that night, right? And came back so excited in the lab being like, there's all this work and we haven't applied it to honeybees. What if mites are moving from one host to another and the disease transmission dynamics are similar to mosquitoes? We could build off of all the work they've done. Well, it turns out mites are like mosquitoes. When they're inside a brood cell, they are encapsulated in that brood cell, but it's like they're in prison for 12 days. Okay, they can't move, they feed on one host. The moment they're outside the brood cell, and we called this phoretic for the longest time, and maybe that's why we ignored them on adult bees, because phoretic essentially means do no harm. They're not, they're causing a lot of harm. They're on adult bees for the purpose of feeding. That's been shown, and we clearly show that again. But they move from one host to another in order to feed. And we had some mites that would feed on average 1 bee a day. Well, over the course of 15 days, that's 15 bees. But if they're in the brood cell, it's only one host, so 1 to 1. But they get outside, it could be 1 to 15. We also had some mites that would only feed on one host for that whole period of time. And that's exactly what is seen in mosquitoes, that there are high-frequency biters and low-frequency biters. And the high-frequency biters in this really awesome Cooper paper in Nature Communications showed those are the ones that drive or shape the disease transmission in mosquito systems. We now think that might be the same thing that's happening in Varroa the honeybee. For the beekeeper, it really wouldn't matter because it's not going to change your management. But what you should know is once you start seeing mites, a lot more of your bees have actually been bit than the number of mites you see.
I think it changed for the beekeeper a little bit about timing,
Yes.
about timing. But what you brought to the table. Let me just do a recap for people at home that might not be familiar with what we were talking about here. So one of your main discoveries in this is that Varroa mites, when are feeding on adult bees, they're jump from bee to bee much more than we were thinking.
Yep.
And that's very important regarding disease spreading, especially viruses that are associated with a Varroa mites transmission. For example, Deformed Wing Virus, which is the model that you work a lot, if I'm not mistaken.
That's correct. Yep.
And you bring this new knowledge that I as a virologist, I thought, that happens. We don't know exactly when those happening, but never crossed my mind it was so bad. I always thought, well, might jump from 1 or 2 or 3 bees here and there. But when I see you're talking about 15 bees, wow, that's more than a 10 orders of magnitude. That's impressive.
Mm-hmm. Yeah, and that segues into, I did make a presentation for you briefly, but this is kind of working out as a nice format. This segues into the next paper, because in this Promiscuous paper, we didn't have on a population level. So on the individual level, it really matters. If you were to think of you as a person, if you were bit by a mite, it really matters if that mite has virus or no virus. If you're parasitized by a mite and it has no virus, you're fine. Okay. You're going to live for, on average, long periods of time, and you're going to die at the same rate as your non-parasitized nestmates. That mite has virus.
So glad you're saying that. I'm so glad you're saying that. We're going to... Keep going.
Okay. But if you're bit with the virus, you're going to drop like that. I had a video I had segged up for you. We do this in the lab, and we'll see 24 to as early as 36 hours later, these bees are falling and acting crippled and dying very quickly.
Wow.
You don't want to be that bee. If you're a human, you do not want to be that bee.
Yeah.
But you want to be the nestmate of that bee. Because that being a bit... Yeah, think of it this way, Umberto. Let's say you and I are actually hanging out, chatting, doing this over a coffee shop, and a parasite bites me, and I die super quickly. You're safe. You're totally protected. But let's say I live for the whole time in that coffee shop with you, and I'm able to transmit that virus to you during the time that we're talking. You're no longer safe simply because I lived. So on the population level, we actually see the same amount of death when at first there's no virus with the mite amongst the whole group of bees compared to the same drop of death in that. And that led into that second paper there.
Yeah, let me put the screen, the second paper here, just 1 second. If you have a presentation for us, I'm not against that. I'll tell you that.
Okay, we can go ahead and do it. Let me just throw, I thought we were only going to do...
Well, this is the second paper, just for me to illustrate the people at home. So the second paper was published on the Proceedings of the Royal Society Bees, a very, very prestigious journal. And the title is Susceptible and Infectious States for Both Vector and Host in a Dynamic Pathogen Vector-Host System.
It's a mouthful.
It's a mouthful, and that's the thing that we discuss a lot in the academy. I have my academy, which is some of the members are here today watching live. Members of the academy is able to watch those conversations live so they can follow and ask questions at the end. But this is one of the exercises we have at the academy, is just, get those papers with this, mouthful titles and try to slowly dissect them and try to translate them to a language that normal people can understand.
I know, the original title I really liked. Jay Evans came up with it. It was Oversharing Between Hosts and Vectors. And, the reviewers, to their credit, it's not the most accurate.
I know.
But for broadly understanding what we're talking about, it's so great to connect with the public because you understand the concept of oversharing, and then there's a pathogen involved. I loved it because it was so simplistic to me.
That's what I like your background. You have that in your mind to communicate with us, the normal people in the ground. This title is for researchers, for people, scientific people that it's gonna, they understand. But for, I remember if I showed this to my dad, he's probably punch me in the face,
Yeah. So it's a mouthful. I mean, it's very accurate, but it's a mouthful.
It is. It has to be. It's two different worlds, and when we are in between those worlds, that's why I think very interesting things can come up. So that's why I like the position where you are in your career. So, what do you want to do? Do you have the presentation with you? How do you proceed?
Yeah, I can do that. I will say before we go on, though, even though we're picking on academia a little right now, because
I'm not picking. It is what it is.
Okay. Well, I do like that rigidity in some ways because we don't have flexibility necessarily to go off into these potential dangerous tangents where something could be hyperbole, or it can be what's the word we use when it's so hard for me to grab words. Sorry. And then there's protection built into that. And so there's this love-hate with it as well. It makes it less accessible, but we don't run the risk of it becoming pseudoscience or hyperbole. Yeah. And so I do like that.
Let me just be very clear here. I do have my problems with academia for other reasons, but science need to follow science rules, and we need to be precise. And that's why we have those titles, and the paper need to be structured and written in certain format, because need to be very precise so we can come back and repeat experiments and get the same results or learn from the process. My problem in academia is the system when they become politicized, and it's not about pursuing the truth anymore. It's become more how they can use you the way they want. But we can talk about that in another opportunity.
Okay. So you want me to click present and?
Yes, click present, and I will put here in the chat. I put here at the screen.
Let me see. I'm going to do share screen. It's easiest with two monitors, so let me plug in my other monitor.
Okay, don't worry. So for people at home, it's a fascinating publication where Zac, well, you're going to talk about it. I don't want to go ahead and take the surprise, but he had very interesting findings regarding the Deformed Wing Virus and the virus, what directions the virus go in this transmission between vector, the honeybee, and viruses going from Varroa mite to Varroa mite themselves, which is quite interesting.
I think I did this correctly. Am I sharing a screen? Okay.
Oh.
I can't see you anymore, so that's the only disappointing thing.
Yeah, that's the only thing, but I'll control everything from here, so don't worry. And yeah.
Okay, and Umberto, I don't know how much time we have, so feel free to cut me off, tell me to speed it up, and if I'm not being fun for your audience, make sure that
no, I think the people gonna like this very much. Don't worry about if you don't have any other place to go, I'll keep talking to you for hours, so I have no problem. It's up to you.
Okay, I freed my morning for you. I got a doctor's appointment at 1:15, and oh man, I'll jump right in on this. I share with beekeepers who are trying to scale up the issues I made with my business, and some of them was ignoring problems, and I ignored this Achilles damage that I was doing. Oh my gosh, for so long, and now I'm paying for it.
Oh, no.
So if you've got a problem as you're growing your business, find someone who's not a spouse, not a close friend. Find someone who's separated and tell them about the problem, and they'll be able to give advice because they're not emotionally involved in it and do that. But anyways, so this is Varroa. And so if you're a beekeeper, this is the thing you'll hear me say, we talk about it more than we talk about bees themselves. And it's an ectoparasite that feeds on both developing brood and adult bees. The thing I really like to point out with this slide right here is you have two types of parasitized bees right here. You have one that is being parasitized as an adult. That's in the center here. And that's where, from the previous conversation we had, mites are going to move on to this bee and feed upon them. And this particular adult is an asymptomatic bee. meaning it's parasitized. It likely received an injection of virus from the feeding of a vector on it, but it's not showing any morbidity or symptoms. So it's asymptomatic. However, the bee over here on the right, this was parasitized during development. So it might actually entered its larval cell to feed upon it. It vectored a virus that migrated to the bee's brain, causing these deformed wings. And beekeepers really like to point out this bee because it stands out from every other bee in the colony. It's morbid. It has a shortened abdomen and crippled wings. And so we have these two kind of types of bees I'd like to point out. We have a symptomatic one and an asymptomatic one. We have one that was parasitized during development, one that's parasitized during adulthood. We overwhelmingly study and as beekeepers worry about this symptomatic one. But this asymptomatic one is actually more prevalent in a honeybee colony, and I believe actually causes far more damage to the rest of your bees in a colony. Varroa reproduce inside of brood cells, so they'll go down and feed on that developing larvae, and when they leave, they're no longer entombed inside of that pupal cell, so they can actually have lots of opportunities to feed on adult bees. And that's our main finding from that PLOS Pathogens paper that we were just talking about. We knew that mites moved from bees. We had some early laboratory trials showing that 50% of mites would leave its original host within 24 hours. But what had never been calculated was the frequency at which these mites do it. And also, what's the relative risk of a mite bite? So how likely am I to die if a mite moves onto me and feeds onto me versus maybe a different mite with or without a virus that moves on to another bee? So some of these bees are going to move really slowly, and some of them are going to move really fast as they move across your adult bee population. There's a huge risk, Umberto, when you have a mite that can go back and feed upon a bee that was already parasitized. Now, we often think of all of our mites as being infectious vectors, but that's not accurate. If you look at every disease system with a vector, not all of your vectors are going to have a pathogen in them or enough pathogen to actually cause an infection in the host. Vectors can actually be what's called naive. So think of it this way, Umberto. Let's say, I don't know if you like fishing. I love fly fishing. Let's say we went out one evening just to, cast our rods, have a couple beers, chat. When we get bit by mosquitoes, we're not going to suddenly die the next day. That's because a lot of those mosquitoes that bite us have no pathogen in them whatsoever, or not enough to actually cause disease. And so we just itch our arms a little and go on with our lives. But if those mosquitoes, let's say, bit a horse or a bird, primarily birds, that have West Nile virus, and then they bit us, now we have a risk of really becoming sick. So sometimes you can have naive vectors and infectious vectors. And what really matters is when these vectors, in our case Varroa, are moving from one bee to another, you actually increase the risk to the Varroa of acquiring a virus. So when you treat or when you manage your mites, I really like to say when you manage your mites, really matters because if you allow rampant viral circulation, you're increasing the risk that all of your mites become infectious. So the cool thing from this paper, Umberto, is that mites are actually a lot like mosquitoes. And mosquitoes follow this thing called the Pareto rule. A lot of you know this is the 20-80 rule. There's a surprising thing that in many aspects of our lives that 20% of something is responsible for like 80% of an outcome. And that's why it's called the 20-80 rule. So for example, 20% of my portfolio, 20% of the equities I buy, they're responsible for 80% of the growth of my portfolio. In parasites, we see the same thing. They form these aggregated distributions. In the case of mosquitoes, it's actually a very, very, very small number of mosquitoes that are responsible for the majority of parasitized people, or I should say, bites inflicted on a human population. And actually, the bulk of your mosquitoes don't do much at all. We really wanted to know, is this what's occurring in honeybee colonies? But a honeybee colony, even if you make the tiniest one, it's still too complex to follow mites. So this is what our laboratory arenas look like. We have a bunch of these cages with individual marked bees in them. And the nice thing about these plastic ventilated cups is we can look right in and track individual mites, all groups of bees. And in case you can see, this one's right here feeding on this adult bee. Well, we ran this work and we get a graph like this. And instead of taking up everyone's time trying to understand the whole graph, what I want you to know is on this horizontal x-axis here, that's number of time in days. My y-axis here is the number of bees one individual mite bit during that time. So this dot approximately here means in 8 days, that mite bit 2 bees. Let's just focus on this column right here. The way we would read this is all of these bees, these light blue ones, they survive for the same amount of time. But these mites down here parasitized 1 bee during that whole 15-day period. Whereas the ones up here parasitized, well, this is jittered, so I think it's approximately 6 times as many as the ones down here. So we see this huge heterogeneity. Heterogeneity means variation in this behavior of Varroa. I was talking earlier, like, from a bee's perspective, which bee, if I was a human, would I want to be? Well, in our studies, if that mite that bit you had a virus, you died really quickly. So these orange bees, these were observed parasitized by a mite. They died super quickly. So you would get bit by a mite and approximately, I think it was 98 hours or 94 hours later, you would die. However, up here, these were the non-parasitized bees. You lived for a long period of time. So if you're in this cage and there's a huge mite coming to feed upon you, you don't want to be bit at all.
Yep.
But if you were in the cage with a mite but no additional virus given, statistically, it didn't matter whether you were parasitized or not. On average, you're going to live for the same amount of time as a non-parasitized bee. But the same number of bees overall died in these 2 groups. And that was a really quirky result because we wouldn't have expected that. And just as a recap, if you have no mite and no virus, you want to be that bee. You live for a very, very long period of time. Mite without virus, we don't know. You're going to die at equal rates. You do not want to be this bee if there's virus involved in that mite.
Yeah. Let me jump in just a second, Zach, because I want to pick up your brain now based on my personal experience. And I have results that I never published and from the past, from 17 years ago, 16 years ago. I was able to visit, I was very curious about Varroa, no treatment Varroa, I don't even know how people call this anymore. Free treatment beekeeping. And I remember visiting some apiaries, and the bees look so good, but they also have tons of mites. And I brought a couple of those samples back to the lab, but that was 16 years ago. I was even with Judy Cheng at that time, and I remember testing those, and I couldn't find a virus.
Okay.
And the bees were good, but I was so scared of the result. I was young at the time. I thought, I don't know what to do with this. And today, after a long time, considering, I was, well, maybe that's why they were looking good. It's the viruses that were causing the problem, not the amount of the mites. Of course, the mites have some damage, but the biggest damage might be coming from the virus. But then I tried to chase that again. I think the environment had changed or things have changed, and I couldn't find those bees again, that situation where there is no virus. So I started to question myself that I did a mistake with my, diagnostic systems in my PCRs or things like that, or if in fact there was in the past or out there somewhere these scenarios that we can find bees with lots of mites but no viruses causing the damage. What are your thoughts on that?
It's not my area expertise right now is in which scenario that could actually exist, because every time we've seen an introduction of mites, we eventually see this really profound amplification of deformed wing virus. And, we saw that very clearly in Hawaii, and really that beautiful paper that came out of there. We'll probably see that in Australia since it's a new introduction. And at this point, I can't speak of, years ago. I mean, I've heard similar things from beekeepers. They used to have thousands of mites on the bottom boards in the fall, and the colony would live. Now we're getting 1% and 2% infestations, and colonies are crashing. So I'm not sure in this current environment if we can say that we could have a vector like Varroa in our bee population and not and extrapolate or separate that from honeybee viruses that it can successfully vector. I just don't know if that's a possibility, and I haven't really considered it. Yeah, so that's my answer. I don't know.
It was a tricky situation. That's why I never published, and I was kind of concerned. Should I even talk about those things? Because every time you talk about those scenarios, create a lot of problems for sometimes with, you are promoting people do not treat the bees. I said, no, this is what I found, but you know how that works. So I was concerned in my early career about that possibility. But, if that case still exists out there, I would like to find a way to prove it. But I think, but I'm talking about almost 20 years ago, and things have changed. The viruses spread even more, and the beekeeping spread even more. Maybe it was true. I found those realities, and maybe it's much harder to find the same realities today. I don't know. I just want to bring this to the people's mind to think about.
Mm-hmm. Yeah, and no, I mean, I absolutely, and we're really working this really as a researcher, a really fun system to work in. As a beekeeper, a really frustrating system to work in, because, and I'll get into that really quickly, but we're always dealing with two parasites. So, at least two parasites. So we have the macro parasite, which is this large mite, and then we have these micro parasites, which are the pathogens that it can vector. And we're trying to breed bees or to maintain host populations that can deal with the large parasite. But when we breed for that, it's almost impossible to simultaneously breed for this microparasite that is going to replicate at high frequencies, and because it's an RNA virus, make errors and mutations at high frequencies. So it's a real frustrating case. I mean, as a researcher, super interesting and fun system to work with, but it's from a beekeeper's perspective, really frustrating.
You said it all. It is frustrating. From the beekeeping perspective, because we want solutions, but from the scientific perspective, you want more questions you answer. So basically that's but keep going. This is very interesting.
So now we're getting into the susceptible paper, and this is the coffee shop conversation that we just had, which is our results from the promiscuous feeding paper. We're like, well, one reason we could see this result where there wasn't a significant difference in the total number of dead bees between the two groups, between mite with no additional virus and mite with virus, is that the parasitized bees, by living for a long period of time in the mite plus no virus group, the virus is replicating inside of them, or they're able to transmit it orally or through contact through their nestmates, and then their nestmates die. And that's actually one of the really scary things about this virus. And I should say this is no longer currently under review. That's been published. And what we ended up doing was we knew from other experiments that deformed wing virus can be transmitted from bee to bee. There's a horizontal paper, and they showed through artificial feedings that you can infect adult bees. We wanted to do the whole arc inside of the lab, going from infectious pupa to mite to bee. And once we get over here, these donor bees, they were parasitized by a mite with a modified deformed wing virus inside the lab. And they were in these dual compartment chambers separated by a screen. And for 11 days, they were able to trophallaxis with these non-parasitized nestmates. Man, this was a really tough study to carry out. It took like 4 iterations to get everything right and not to have a freezer fail on you or an incubator to spike to 40 degrees.
And the right tools to do it. And a big shout out to my friend Eugene Ryabov that create these fantastic viruses that we can when they replicate, you can see You can see them fluorescence in some. I don't know if you use that too, but
yeah, you're doing the correct shout out here because Umberto, you're bringing up
Eugene did a fantastic breakthrough in this model and this whole create this genetically modified virus that once we put in the bees, we can see it. You can see the replication, so we can quantify things.
Yeah, let me jump in on that. So Eugene Ryabov and Jay Evans developed this nanoluke virus, and it serves several key functions in our laboratory. Jay is continuing to use it to screen rapidly for antivirals. It allows him to test samples quicker by using this assay, and far cheaper than doing traditional qPCR. So we can do research pennies on the dollar. Eugene and I worked together, and he had made several clones. And the amazing thing about these clones is we always have deformed wing virus as a potential background in any of our bee samples. So it's really difficult to do transmission work because it could have already been present in our sample. But with this virus, it has 2 inserts in it that have been inserted into its genome. So we can always detect it separate from any potential background virus. As a result, we can do these transmission studies, and it is a huge shout out to what they developed. And the thing I'll just mention right now, in case anyone's wondering, we always use this work in a lab, and then we dispose of everything extra as autoclavable waste. So it's handled really safely. But embarrassed, that's why we're able to end up showing that these recipient bees acquire the virus, and then mites that feed on those bees, they can acquire it and vector it as well. They do it at low frequencies, but they can still acquire and vector it as well. And so we get into this far more complex model where, and that's the title of the paper, your vector can be naive, bite bees, but virus can circulate amongst bees and actually make the vector infectious later on. And your vectors can also transmit virus to each other by feeding on shared hosts. And even other social behaviors of the honeybee can allow circulation of a virus to enter back into a system of other bees. So we get into this really, really complex system that on its face may seem really simple, but when you start to look at individual transmission dynamics, it becomes really complicated when you put them together.
Oh, it is fascinating. What I think is great that you could demonstrate. Some of these things, sometimes we like to imagine, okay, we imagine that's the way it works. Okay, the mite's going to get from the bee, and the bee is going to get also from trophallaxis. And so we have these models in our mind, but, to find a way to demonstrate scientifically, experimentally, is a big shout out to you and all the team at the USDA there. Congratulations to you guys. Phenomenal job.
Thank you. And the really scary thing about this, and the slide just advanced because I hit it, and I'll end this slideshow relatively quick because it's coming up on the end of it. It's far more fun, Umberto, to see your face. But we have very few pathogens that actually have these transmission dynamics. Most pathogens, they're either vector-borne or they can be communicably transmitted host to host, but not both. Deformed wing virus and other honeybee virus, some of the honeybee viruses are both, but a lot of them aren't. And the ones that are in other disease systems, they're really nasty. So Yersinia pestis is a bacteria that causes Black Death. It can be transmitted to host, or vectored by lice and fleas to people, but people can also transmit it to each other. Same thing with like salmon isovirus and other virus and West Nile virus, etc. Yep. And these all actually cause whole population level crashes, just like in honeybees, or they can kill the host really, really quickly. Most pathogens on Earth aren't like this. So it's actually really scary what our bees are dealing with. And in some ways, we really are dealing with a plague in honeybees. And then Umberto, I'll finish this up real quickly, but one of the reasons I really want to study the Varroa model, and hopefully we get to a Varroa solution sooner than later, is we have other stressors on our honeybees and other stressors that are definitely impacting our bees, but they're so difficult to study when we always have Varroa and viruses and other pathogens in the background of our bees, and they could mask those other results. So we'll often get calls for pesticide kills or pesticide exposure in commercial operations. And one of the first things, and I know at this point it's just annoying beekeepers, is we ask them what their mite levels are. Because we want to exclude mites and viruses from this potential equation as a confounder. But unfortunately, sometimes the exposures of pesticides can look like the same effects that viruses can have on your honeybees. So for example, when I'm field collecting bees at commercial operations, I'll collect symptomatic bees that are, which beekeepers may think are actually pesticide exposure, and I'll make inoculum from them in the lab. And we can recreate those same symptoms in the lab when a mite vectors that inoculum into a bee in the laboratory. And because mites are mobile on adult bees, we can actually have multiple bees dying at the same time because they've both been bit just from a single mite. So it's possible that we're getting some of these pesticide reports and it's actually mite viral damage. Well, to me, one of the exciting things could be we figure out Varroa and get it more under control. It's going to be endemic. There's nothing we're going to do about that. It's going to be endemic in our bee populations. But if we can get it under control, hopefully we can actually handle some of these other stressors on the honeybees a little bit better than we are now, simply because Varroa is just such a harsh pressure on honeybees. And that gets me up to my end. I always do a shout out to Ray Evans and Judy Chen and Eugene. Absolutely got me here and really helped this young researcher along, and had a lot of help from stakeholders and such. And now I will close that out and stop sharing. I can see your face again.
Here you go. Oh, that was fantastic. But I'm so glad that you mentioned pesticides in this, because apparently I was a lonely person talking about pesticides for 20 years now. But my visions on pesticides is go beyond what you're talking about. You describe a position that we can't separate the two, and I as a scientist, always thinking, how can I know for sure that things is not caused by pesticides if pesticides are everywhere? No, everywhere. There is no way to separate them. And it's how much of the problems we have today is not because pesticides are putting the immune system down or creating problems to the bees, that all these other diseases and even Varroa mite and viruses taking advantage of. Everything is combined, and if I have to guess, I think pesticides is doing a much bigger, is a much bigger part of the problem that we think. But maybe I want to ask your thoughts on that, because you mentioned you clearly separate the both. And I wish I would. I want to be there with you. Okay, we have that. Let's separate. Okay, it's not Varroa, but then we can go to pesticide. But I think pesticide is everywhere and is a gigantic part of the problem.
Well,
what do you think? Let's discuss this since you bring that up, because I want to pick your brain, because I wanna learn from you today.
Well, yeah. So normally when I approach a problem, I try to break it into its subsequent pieces, because those subsequent pieces are always far, far easier to study. And then I look for the most parsimonious route in which we could go from beginning to end. So if we say pesticides are a gigantic problem affecting honeybees, if we start there, it's just too broad of a topic to actually study and figure out how are they affecting honeybees. And unfortunately with honeybees, one of the really exciting things about the system and also frustrating thing about the system is we get this real chicken and egg situation really quickly. Are pesticides lowering the immune system, allowing bees to develop high levels of virus, and then the mites and viruses kill them? Or is it just present and this was going to happen anyways? And it's so difficult to study that simple question, because if I was to do it in the field, my wax, even if I was to start with virgin wax, is still going to have background levels of pesticides. I cannot control the normal level of exposure to my colonies in any field trial. And some colonies are going to go to sources that have way more higher levels of pesticides in unequal levels or types than my other trials. So we get these huge confounders really quickly. And on top of that, that work is so tedious that we usually have very few replicates, and it's really expensive. So we have all of these roadblocks. And I find it really frustrating. And if we were to do it in the laboratory, great. Now we can control our environment. We can control the confounders. We can control the experiments. But they're so far removed from laboratory or from field settings that we can't always extrapolate the results. One of the really frustrating things I felt as a beekeeper was I would read a paper about how a fungicide's affecting honeybees, or how, something like glyphosate or chlorpyrifos is killing honeybees or affecting them. And then you're like, well, where's the regulatory change? If we know this is happening, where's the regulatory change? And our system doesn't work like that or that quickly. But also those were largely laboratory trials, and those results don't always extrapolate to the field. We don't see them in real world settings. So to me, that system is so complicated that if I was to if you were to say, here's $1 million, 5 years worth of continued funding, just go at that. Oh man, I'd have to really think about how we break this down into testable components, separating confounders, and then also making it real world enough that the data that we get is I just used the word and now I can't use it again. Sorry. Well, I don't know the answer, but unless
it's confusing. Yeah. It is a hard one. Go ahead.
Yeah, and I'm really shy about making statements until I actually see risk assessments. So there's some really great papers in terms of determining hazard quotients for pesticides. But we actually, other than, we had some economic thresholds on whole colony levels, we actually didn't know a lot of risk assessments for, parasitism on adult bees or viruses on adult bees. And one of the small components of the paper, that Promiscuous paper, is we actually had relative risk assessments of a mite bite. I really want to see that also on individual bee levels or on developing brood, so that we can start to make these quantified assessments. And that's the type of data that's really boring and hard to share. But once you have more of that data, I feel like we can make better decisions going forward. And some researchers have done tremendous jobs at that. It's just really complicated to get there.
It is
expensive. It's so freaking
expensive. Very expensive, exactly. And that creates a problem. How are we going to know things if we cannot research them accordingly and isolate the factors and the variables correctly to perform to do the assessment? So then end up trusting my beekeeper's background. Like, okay, if I need to guess, because as a scientist, I cannot isolate all the variables. So with the information that I have around me, so what's my gut is telling me that what I don't like is we always drifted the conversation very fast and forget about pesticides. I don't want people forgetting about pesticides. That's all.
Well, then, as a beekeeper, what I really suggest, though, is taking all of the stressors that are in your control and controlling those, so that when you have to make an assessment on why a colony died, which, by the way, I think is now just a really boring question, right? We keep asking these questions like, why did my colony die? And I'm like, these are bad questions. But anyways, if you have a lot of the stressors that are under your control managed, then you can make better assessments on what the other stressors probably has an impact. So what I mean by that is, let's just say you're requeening in the middle of summer and your queens are shipped from Hawaii or California in the middle of summer. And you're like, was it heat stress on my queens during shipping that caused the failure, or was it pesticides? Oh man, when you have confounders like that, you can't test that in real time in your operation, right? Or was it just poor breeding? So when you can remove confounders like that, fantastic. Nutritional stress is a real confounder that beekeepers have under their control. If you're going in and you're like, my colony's light, but you're not sure if it's, pesticide exposure or a poor queen, feed the colony, right? It's a real quick way to start to remove one of the stressors and to be able to make good decisions. And so you'll often hear me say split, treat, and requeen. And part of that longer conversation is, if you can get your colonies to a baseline where you know that they're headed by a well-mated queen that hasn't had previous stress in her development or shipment, and you can manage mites before rampant viral circulation and damage to your worker bees. And they've been fed. Now going forward, you started kind of at a baseline, right? You'll be able to make better decisions because you've taken 3 of the biggest stressors right out of the equation. Now when you approach me as a researcher, I've done this. We're pretty certain these aren't the problems. We think it might be this exposure from, mixed batch spraying at apples or something like that. And then we can approach it much easier. We had a stakeholder last year. It was one of the easiest stakeholders to work with. Tremendous guy too. And he had so many things like that under his control that at one point he was really able to communicate to JME and the team, like, I know it's not Varroa. This is how I've managed it. These are the samples I've taken. And long story short, his bees were cleaning up EFB so quickly that we barely saw any symptomatic bees, but they were cannibalizing whole droves of larvae. So his adult pea population was always small. He had so much under control that by the time Jay and I are really talking about it and starting to talk with Sam in our lab, we went to a couple brood diseases. And when we got hits on that, he was able to fix it. But what he did was he managed those other confounders that were under his control. And as a researcher, now we're trying to make assessments with all of these other possibilities no longer part of the equation because they couldn't have been part of the equation. And I always encourage beekeepers, whether you're a hobbyist or a commercial, to try to reduce those confounders, and you can make better decisions. If you start to introduce complexity into your decision-making, that's on you, right? That's where you got to step away and say, is this a parsimonious assessment?
That's big part of my consulting business is to educate beekeepers to through the thinking process, exactly just like you said, we need to, let's take this factor out, this out, this out. Now, you start to get rid of the noise and to dig until we find something that we can work on. It's never, because it's so many factors, it's never a situation that we know exactly what it is. But when we start to dissect a little bit better, we can try different things that we're able to measure success. And that's the only thing the beekeepers care about is, especially the commercial guys, if I can bring some value with whatever we put in the table. If they invest this amount of money, how much money they're going to get back.
Yeah. You're bringing up something I really like about commercial beekeepers, which is a lot of them are good business men and women, and they're willing to make investments when they know they'll have a return on that investment.
Yep.
And all the conversations I've had this year, all of those returns on investment were about their bee health, right? They're not asking me, how can I make more colonies? They're not asking me, how can I get multiple pollination services just by going bam, 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 bam. They're not looking at it, trying to get more efficiency out of the colony. All their investments right now are into, at least from my conversations, are on honeybee health.
My conversations too is because it's simple. It's very simple, Zach. It's a misconception among people. Some people see the commercial guy. Yeah, there are some bad apples there that don't care about the bees at all and just move bees like crazy and don't care at all. But there are a lot of commercial guys. Because it's true. There is only one way to make money with bees, is with healthy bees. Mm-hmm. If the bees are not healthy, they're not going to produce, they're not going to survive. So they need to focus, and they have systems in place. But because of some bad apples, I see a lot of even discrimination sometimes, talking about commercial guys in a bad way without making sure that guy is a bad apple. But I know a lot of big guys that have fantastic bees and have fantastic procedures to keep the bees very healthy. And they're making a ton of money with that.
Yeah. And, I did some field sampling in Florida and California this year. And I think hobbyists often get kind of put commercial beekeepers into this cliche that they're just treating, they just have a lot of colonies, they're just moving colonies. Whereas if you have an in-depth conversation with a commercial operator, and even lots of time their crew, they know their treatment schedules, they know their splitting sheet schedules. They can tell you with whole droves of colonies where the queen source was, whether it was a cell or an introduced mated queen. And they have a lot of them have really good SOPs.
Yeah.
Whereas if I have that same conversation on average, I should say on average, with hobbyists, I don't get that specificity in terms of treatment schedules, what the dosage was, queen sources, et cetera, like that. And so there's this little bit of disconnect. And I think it does a disservice to commercial beekeepers, who a lot of them are really doing a tremendous job with the information they have and within this really weird marketplace that they have to operate in. So
it is an interesting conversation to have about this misplacement, how people view people, because it makes sense, when your livelihood depends on the health of an organism, you're gonna care about the organism a lot, and if it doesn't, if the organism in this case the honeybees are not healthy enough to move the operation forward, they're gonna suffer. Their family is gonna suffer. So they pay a lot of attention on that, which is different than backyard beekeepers. Backyard beekeepers, sometimes they treat the bees as pets, and not and a lot of them have a lot of love for them, but they're not able to keep the bees as healthier as some commercial guys that I know, which is quite interesting, based on people's perspective. Mm-hmm. So cool, Zac. You're doing fantastic things, my friend. I'm so happy for you. I'm so happy that you are still in the field with these two backgrounds, and I'm sure very interesting things gonna come on your way based on the way you think about beekeeping and bee research. So myself, in the name of Inside the Hive.tv audience, so I want to thank you and all your team for the great work you're doing. Keep doing, man. And if you need anything from me, please never hesitate to ask.
Okay, Umberto, thanks for this opportunity this morning to chat with you on the podcast, and feel free to reach out again. I'm really psyched about working with our collaborators and the crew at the USDA. Especially working under Judy and Jay has just been fantastic, and so we're really excited about kind of the next couple of years of work that we'll be putting out.
Yeah, I will keep looking at the work you guys are doing and bringing to the podcast much more information, because the USDA, the Beltsville lab, is fantastic and always producing good quality work and good quality honeybee researchers. Zac, in the name of Inside the Hive.tv, one more time, thank you again, and I'll see you guys in the next week. Inside the Hive.tv, the show about bees. Bye-bye.
Thanks, man. See you later.